Namaskar, welcome to Toxicology on Board channel. Today we'll discuss in this video about the topic inhalation toxicology, respiratory system, some of the definitions we will be discussing, and also we'll discuss about particle size, particle size is going to affect the inhalation toxicology. So let's go directly to the question. This particular question which we are going to discuss in this video is not a recertification DABT question, but rather this question is taken from American Board of Toxicology Design Execute and Interpret Toxicology Studies quiz. Okay, I think in the DABT site, I guess this particular was there long back. Not it's not there. I suppose it's not there currently in the website. Around 50 questions which are framed by American Board only are there in this particular paper. Okay, and they have also given the reference, they have given the explanation also why the right answer is. So uh, in my upcoming videos I will be discussing, today we'll discuss question 1, but in my future videos I'll be discussing rest of the 49 questions, their explanation, and we'll also try to learn other options also why they are not applicable for that particular question. Okay, so let's directly go to the question. The question is, what size or dimension of inhaled particles would favor their deposition in the respiratory alveolar region of the lung? Okay, so the is asking because the topic is particle size, how the particle size of the inhaled, whether it may be gases or aerosol, whatever it is, how the size or dimension of the particles is going to impact the inhalation toxicology. Okay, in which part of the region of respiratory system and it is going and depositing, that we will learn in this particular video. Okay, let's see what is option A. Option A is greater than or equal to 2.5 micrometer in diameter. Option B is less than 0.01 micrometers in diameter. Option C is 1 into 200 micrometer elongated fiber. Option D is between 0.01 and 2.5 micrometer in diameter. The right answer is option D. Okay. Uh, let's see what explanation and reference which is given by the American board only. Okay. Particles reach the alveolar region on the lung by sedimentation and diffusion. So this is not actual diagram from the textbook. In next slide, I have given the diagram from the Clayson, but for let us understand approximately how the particle size is affecting. If the particle size is inhaled particle size is greater than 5 micrometer, the particles will go and trapped in the upper airway system. Okay, if the particle size is greater than 5 micrometer, if the inhaled particle size is 1 to 5 micrometer, it will go and deposit in the deeper part of the lungs. Deep lung deposition takes place. If the particle size is less than 1 micrometer, it will reach the alveoli, reach pulmonary alveoli. What is the mechanism? Through diffusion. And if the particle size is around 500 nanometer, it will be phagocytosed by the alveolar macrophages. That is the thing it is saying. The particles reaches the alveolar region on the lung by sedimentation as well as diffusion. Okay. Next, sedimentation is not favorable for particles less than or equal to 0.5 micrometer. Okay, aerodynamic diameter, but diffusion is favorable for this dimension down to 0.01 micrometer. So less than equal to 0.5 to 0.01 micrometer, diffusion takes place. Okay, then next, particles greater than 2.5 micrometer would be trapped in the upper airway by impaction. Again, we will be learning about what is impaction, what is diffusion, what is sedimentation in the next slide. Okay, and an elongated fiber would be trapped in the bronchial tree by interception in this one. Okay, fibers, elongated fibers, and the mechanism is through process is through interception. Okay, you can read about this in Casret and Doll 8th chapter. Page numbers are already given. Okay, this is given by the ABT itself, American board only. Okay, so here you can see, if the particle size is 0.1 micrometer, particle deposited in the alveolar regions. If the particle size is 2.5, it is going and deposited in the lung. And if the particle size is 10 micrometer, it is deposited in the, so as the particle size decreases, it will go and penetrate deeper layers of the respiratory tract. Okay, that is the reason smaller particles deposited in the alveolar regions and larger particles, for example 10 micrometer, deposited only in the upper respiratory. This is only in the mouth. Okay, so very quickly we'll run through what major important components in the respiratory system. Nasal airway is there, pharynx, trachea is there, bronchi is there, which will further branches into bronchioles, and respiratory bronchioles are there, alveolar duct and alveolar sac. These are the alveolar. So here the smallest particles will get go and deposit. Larynx, then lymph nodes are there, pulmonary arteries, pulmonary blood vessels as well as alveolar capillary bed. So let's see some of the important particle size and deposition. If the particle size is greater than 5 micrometer, nasopharyngeal region, this particular region, it will get deposited and it is removed by blowing of nose. Okay, simple sneezing can remove such a size of particles, it is stating. 2 to 5 micrometer if the particle size is, it will go and deposited in the tracheobronchial region, removed by ciliated cells by mucociliary escalator. That is always purpose of this mucus is it will try to remove the unwanted particles through the nose. Okay, track by continuous movement of ciliated cells. Okay, then next, if the particle size is less than 1 micrometer, penetration to alveolar sacs may be cleared by macrophages or lymphatic. So we have seen in the previous slide that alveolar macrophages are there which will engulf this particular size of the particles. Okay, so let's see some of the important respiratory definitions. Okay, what is a gas? Gas is a substance in the gaseous state at normal room temperature and pressure. Okay, vapor. See, these terms might appear very simple, but when it comes in the form of options, no, we will not be able to understand it. So it is better to have a quick revision, understand each and every term. Vapor, the gaseous phase of a material that is usually a solid or liquid at normal room temperature and pressure. At room temperature, solid or liquid. Okay, aerosol, a relatively stable suspension of solid or liquid particles. Okay, next, dust, solid particles produced by grinding, blasting or milling. So this is the way dust is formed. Okay, then next we'll also learn in this video about photochemical smog also. Okay, how it is formed, how it is going to impact inhalation toxicology or respiratory pollution that we will be seeing in this particular slide. What is haze? Haze is vapor, dust or fume, mist or smoke that reduces visibility. Okay, so there will be some kind of difficulty in case of driving. Fume, solid particles formed by combustion or condensation of vaporized materials. Okay, usually quite small, less than zero point 0.1 micrometer. Example, metal fume fever produced by zinc oxide. One of the important topic again in case of DABT is they will ask which of the following metals will cause metal fume fever. One of the option will be zinc. There are some other metals are there which also cause metal fume fever. It's a take this as an homework and you can go back and check. In some other video, I will definitely list out all the metals which causes metal fume fever. Okay, in my previous slide when we were discussing about mercury also, I had discussed about mad hatter disease. So that is also one of the metal, how industrial area, industrial workers, if they are working with a certain metal for a long period of time, there will be some occupational hazards will be there. So in that case, mercury exposure, by keeping that mercury containing hats, it causes mad hatter disease. So similarly, metal fume fever is there which is caused by zinc, and there are some other metals are also there which are responsible for causing metal fume fever. Okay, next is smoke formed by burning organic material. Okay, mist or fog, aerosols of liquid droplets formed by condensation of liquid or particles in the air. Smog formed by car exhaust, also called petrochemical smog. You have to learn in this case of inhalation toxicology topic, two types of smog you have to learn about. One is Los Angeles smog, another is London smog. Okay, how these two are different, that you have to learn. Ozone has the highest oxidant potential in smog. So smog contains various constituents will be there. There will be ozone will be there, oxygen radicals will be there, pan peroxyacetyl nitrate will be there. Okay, so next slide we will see what is the composition of smog. But important thing you have to remember here is that ozone has the highest oxidant potential in case of smog. Okay, ozone causes oxidation of the unsaturated fatty acids and it can be prevented by vitamin E. So whenever there is oversaturated oxidation of unsaturated fatty acids has taken place with ozone, that can be prevented by using vitamin E. Okay. The next, lung damage can be duplicated by injection of ozonide of linoleic acid. Okay. Age of animals also responsible for this toxicity, and ozone can be generated during stainless steel welding. So these are the various ways through which ozone can be released into the atmosphere. Another important definition that you have to remember is MMAD, that is mass median aerodynamic diameter. The material behaves as if it was as spherical particles of a particular diameter. Note that the real diameter may be different from the MMD. Okay, so if you see these definitions we were saying, no, we'll discuss about what is impaction, what is interception, what is diffusion, what is sedimentation. Okay, respiratory system definitions. First one is particle size. Particle size is usually the critical factor that determines where in the respiratory tract a particle or aerosol will get deposited. Okay, throughout the video we're discussing that is only based on particle size. Particles that are soluble in the mucus may be absorbed before they can be cleared. Okay. Next, interception. Here you can see interception. Interception means the particle contacts the surface. Particles enters the respiratory sac. It will contact the surface. This is important for case of fibers. Interception is determined by the fiber length. As the fiber length increases, how much interception will be there, that will be defined. Okay. Then impaction. Impaction uh, impaction occurs in the bending airstreams. Here you can see. Okay, because whole respiratory system ending into bronchioles or have many bifurcations will be there. Okay, bendings will be there. So impactions occurs in the bending airstreams. The particles may impact at bifurcations. Impaction is greater for particles in the center of the airway and particles greater than 3 micrometer. Okay, particles with aerodynamic diameter 5 to 30 micrometers are generally deposited in the nasopharyngeal region by impaction. Okay, next, sedimentation. So let's learn what is about sedimentation. Sedimentation occurs in smaller bronchioles. Here, bronchi, bronchioles, and alveoli where the airflow is low. Okay, the particles settle because of the gravity. Sedimentation occurs if mass median diameter is greater than 0.5 micrometer. If the particle size is very small, then this type of sedimentation takes place at the deeper layers of the respiratory system, that is bronchi, bronchioles, and alveoli. Particles with mass median diameter of 1 to 5 micrometer are generally deposited in the tracheobronchial regions by sedimentation. Okay, let's see what is diffusion. Diffusion is Brownian motion. Diffusion occurs if the mass median diameter is less than 0.5 micrometer. Diffusion occurs in the alveoli. So you have to learn what is interception, what is impaction, what is sedimentation, what is diffusion, okay, and what are the particle size, how they are going to affect different type of methods of deposition, okay, in the respiratory tract. Then this is taken from Clayson 9th edition, page number 823. I would request, till now we were discussing about the particle size they enter into and types of, but certain times what happens, after entering into the body also they will undergo either condensation, they will undergo either nucleation, or this type of process will take place where the particle size may increase or decrease. Okay, so this particular diagram you please go and read in this page number 823. Okay, then we'll also learn about two types of smogs, that is photochemical smog and industrial smog. Photochemical smog, also called as London smog or industrial smog, it is seen in the case of New York City, and Los Angeles smog, also called as brown air smog. So major differences between these two type of smogs we will see. Major sources for industrial smog is household burning and coal oil, whereas photochemical smog is basically it is caused because of the motor vehicles. And major effects on the humans you can see in the case of industrial smog, it is because of it causes irritation of the lungs and throat, whereas photochemical smog causes eye irritation. And industrial smog is generally it is seen in the case of winter months, especially in the early morning in Delhi. You can not you when those people who are living in north, they will know in Delhi. So this type of industrial smog you can see, whereas photochemical smog can be seen in summer months, maximum effect around noon. So another important concept that we will learn in this video is, as I said, how this photochemical smog is formed. So whenever there is nitrogen oxide is available, and in the atmosphere, in the sunlight, presence of photons, HV, high energy particles will be there. They will react together, form nitric oxide and oxygen. Free oxygen is formed. This free oxygen unstable. It combines with molecular oxygen and form ozone. This is the way ozone layer is formed. Okay. Again, some of the nitric oxide will combine with ozone and this form nitrogen dioxide as well as oxygen. Okay, this nitric oxide again combines with some of the alkyl groups, whether CH3 or something like that, alkyl groups, and it forms pan, acetyl nitrate. Okay, acyl nitrate. Again, this nitric oxide it will combine with the highly reactive alkyl oxide groups and forms NO2 as well as other products. So these are the major components of the smog. Okay, and ozone is the most important one, which is responsible for causing oxidant property. Okay, when I checked, there are some more other reactions are also there available for this formation of this photochemical smog. I would request you go back and read Clayson or Hayes textbook like this. In that, more detailed discussion will be there about this formation of this photo. Once you make a notes of this one, so it will be very useful for you at the time of revision. Okay. So hope you were able to learn from this video about inhalation toxicology, particle size, how it's important in the case of respiratory system, and different types of definitions we have learned about sedimentation, impaction, interception, etc. Okay, able to learn. We were also able to learn about the differences between two types of smog. Okay, so be curious. If you have any further doubts, please comment, mail either or mail to arya.priyanka18@gmail.com. Like, subscribe, and follow my YouTube channel Toxicology On Board. Thank you so much. All the best for your exam. Thank you.